This section covers how to protect data in transit. Data in transit is actively moving from one location to another, such as across the internet or through a private network. To protect data in transit, you protect data while it's traveling from network to network or being transferred from a local storage device to a cloud storage device. Wherever data is moving, protection measures are critical, as data is often considered less secure while in motion. When data is in transit, what risks is it exposed to? Accidental information disclosures, data integrity compromises, identity compromises, which include man-in-the-middle attacks, and identity spoofing. A man-in-the-middle attack is a form of cyber attack in which criminals exploit weak web-based protocols to insert themselves between entities in a communication channel to steal data. This type of attack makes the network vulnerable to packet sniffing and modification. You can protect data in transit by using Secure Sockets Layer, or SSL, or client-side encryption. You can securely upload your data to or download it from Amazon S3 through SSL endpoints by using the HTTPS protocol. You can limit access to an S3 bucket from a specific Amazon Virtual Private Cloud or Amazon VPC endpoint or a set of endpoints by using S3 bucket policies. To protect data in transit, AWS encourages customers to use a multi-level approach. All network traffic between AWS data centers is transparently encrypted at the physical layer. All traffic within a VPC and between peered VPCs across AWS regions is transparently encrypted at the network layer when using supported EC2 instance types. At the application layer, customers have a choice about whether and how to use encryption by using a protocol such as Transport Layer Security, or TLS. All AWS service endpoints support TLS to create a secure HTTPS connection to make API requests. Protecting data in transit includes protecting remote connections to servers. Users who access Windows terminal services in the public cloud usually use the Microsoft Remote Desktop Protocol, or RDP. By default, RDP connections establish an underlying SSL or TLS connection. For optimal protection, the Windows server being accessed should issue a trusted X509 certificate to protect from identity spoofing or man-in-the-middle attacks. By default, Windows RDP servers use self-signed certificates, which aren't trusted and should be avoided. For Linux servers, Secure Shell, or SSH, is the preferred approach to establish administrative connections. SSH is a protocol that provides a secure communications channel between the client and server. SSH supports tunneling, which you should use to run applications such as X Windows on top of SSH and to protect the application session in transit. By default, Amazon Machine Images, or AMIs, that AWS and most vendors from the AWS Marketplace provide don't allow the root user to log in from an SSH terminal. The default configuration for AWS-provided AMIs is logging in with an SSH key pair with password authentication deactivated. With AWS Certificate Manager, you can provision, manage, and deploy public and private SSL and TLS certificates for use with AWS services and your internal connected resources. Managed renewal and deployment through ACM can help you avoid downtime due to expired certificates. AWS Certificate Manager Private Certificate Authority, or ACM Private CA, creates private certificate authority, or CA, hierarchies without the investment and maintenance costs of operating an on-premise CA. Your private CAs can issue end-entity X509 certificates, which are useful in scenarios such as creating encrypted TLS communication channels, authenticating users, computers, API endpoints, and Internet of Things, or IoT devices, and cryptographically signing code. These certificates are also helpful for implementing Online Certificate Status Protocol, or OCSP, to obtain certificate revocation status. ACM Private CA is for enterprise customers who are building a public key infrastructure, or PKI, inside the AWS cloud. The service is intended for private use within an organization. Certificates that a private CA issues are trusted only within your organization, not on the internet. After creating a private CA, you have the ability to issue certificates directly, that is, without obtaining validation from a third-party CA, and to customize them to meet your organization's internal needs. Let's look at an example of ACM Private CA in action. First, The CA administrator creates a subordinate CA to issue certificates. Next, the subordinate CA sends the certificate to be signed. The on-premises CA, or AWS CA, signs the certificate. And finally, ACM Private CA issues the signed certificate to resources. ACM Private CA is secured with HSMs. These HSMs adhere to FIPS 140-2 Level 3 security standards to help protect your private CA against key compromises. CA administrators can also control access to the service by using IAM policies. ACM Private CA publishes and updates certificate revocation lists to an S3 bucket automatically to help prevent the use of revoked certificates. For instance, an IoT application can check if the private certificate for a sensor is valid before accepting data from the sensor. ACM Private CA creates another S3 bucket that provides the ability to generate audit reports. Here are the key takeaways from this section. Protect data in transit by using SSL or client-side encryption when you run applications in the cloud. Use VPC endpoints to limit access to S3 buckets. The ACM service handles the complexity of creating and managing public SSL and TLS certificates for your AWS-based websites and applications. ACM Private CA can manage the lifecycle of your private certificates centrally and in a highly available way. Thanks for watching.